Welcome to another Bryanston School IB2025 tutorial video. In this video we're going to be taking the 3D model that we created in Onshape and putting it into the Bambu Labs slicing software so that the model could be 3D printed. So I've opened up the Onshape and open up the model that we had worked on previously. If you've left it on the drawings, go back to the Part Studio. And here's the model. So the first thing we need to do is export these model parts into files that the slicer software will understand. So we're going to use STL files, stereolithography files. So we can just right click on the part and select export. And you can see that it tells us what the Part Studio was and what the part is. STL is the format, binary, millimeter, fine is fine. We can just leave the defaults there. We're going to export that and we're just going to put that into downloads and click on save. And we can do that with the other parts, and I can also do it over here, so I can right click on legs and export and save. And do it again for the lens holder. So right click, left click on export, leave all the defaults and export that and save it. So we're going to switch software now. We're going to go to Bambu Labs. I've opened it up. You would need to install this on your own device, or the school computers will have them for you, or we'll have it pre-installed for you. Open up Bambu Labs software, and you're quite often greeted with this. Sometimes you get messages about upgrading and things like that. I'm just going to click on prepare, and that takes us through to showing us the bed. Now the first thing to check is that we've got the right machine and the right materials set up. So we need to make sure we're on the Bambu Lab X1 carbon with a 0.4 nozzle, and that we're using a textured PEI plate. There are some different choices, but you tend to find once someone's used that on the machine, the defaults will go to that. But it's just worth double checking, otherwise you might try and print something and it won't work on the printer. So this is the bed, the build plate, that part goes into the back of the machine. This is at the front, and it shows where it will do a little nozzle check when it's printing. So we need to get the parts in here, and we can do that one of several ways. We can drag and drop them in, or we can go to File and import the STL files. So if we do that, we can actually select all three at the same time and go open. If you do that, it says, do you want to create a single object with multiple parts? In this instance we don't. Sometimes it can be useful. So there are the parts, and they're all on top of each other. So I'm just going to left click out the way to deselect them, and then I can drag the three parts around separately. Unlike Onshape, you have to hold the left mouse button down to move this around. Those are the parts. What we'll first of all do is lay them down on the bed. Now when we're printing, there's quite often a compromise between strength, accuracy and speed. So depending on what we're after might depend on how we will lay the parts out, the orientation of the parts. Let's take the this part as an example, the head. It makes sense for this, and I'm going to click on this tool here, which allows us to pick a face to lay it on. It makes sense to put it down facing downwards, because we'll get the most accurate circle then. But what it does mean is it will be in lots of layers, and if it was going to break, it would break across these layers. But actually the material's quite thick, so that's not a problem. Likewise, it makes sense for this to be nice and accurate, to print it with this flat surface on the bottom. So again, I'm going to click on lay on face, select that part, select the face, click away, and I'm just going to scooch that over there, just dragging it. And then the feet, this is a little bit more complicated. If we wanted to try and get maximum strength on these, we would probably want to orientate these so that they're lying on their side. So we'd probably want to print them in this sort of orientation. The reason being is that the printer will go around the profile of the legs, and this will give us a strong shape. However, for the purposes of speed and making things easy, we're going to print them with the feet flat on the floor. So we'll do that, and I will just drag that over out of the way. Now you can see that sort of twisted around slightly. It doesn't that doesn't matter really, but what this does mean is as it's layering, it'll be printing across these. Now if it was printing with layers going this way, this would be quite weak. I suppose the weakest part on here is going to be the layer across there, where arguably the feet could snap off, but this will print relatively quickly for us, and we're not going to be knocking this about a lot. If we were doing these as separate parts, perhaps if we were articulating them, in that case we might actually lay these down and build them on their sides and do them separately, but for the purpose of this, it's absolutely fine. So we've got our parts. We can just move that around with the left mouse button and look down, make sure that we're not interfering with anything. I suppose we could spin that around slightly so it looks a bit squarer. It's not going to matter, it'll still print okay. So let's go over to the settings. Pretty much the default settings will work. In school we tend to use Bambu PLA Basic. Bambu Labs PLA Basic is the material. That's a biodegradable material, and that works really, really well. It gives us some really good quality prints. We would normally stick to a layer height of 0.2 of a millimeter. We could go to 0.1 if we wanted a slightly smoother model, but that's absolutely fine. And pretty much everything else we can keep the same. If we go to strength, we've got wall loops. Now what a wall loop is a 3D printer doesn't print things solid. It prints things by doing a skin. So if we take, for example, our head here, it will print an inner skin and an outer skin, and then it'll do a partial fill on the inside. And the standard fill is usually about 15%. So you can see on here, it's going to do a grid infill of 15%. That uses less material, but still gives a good amount of strength. If we want something really strong, we could increase the amount of fill percentage. And likewise, we can have more wall loops. So it's going to do 2 loops. It's a 0.4 nozzle. So the walls will be 0.8 millimeters thick. If we wanted a really strong part, we could perhaps do 1.2 millimeters, or go up to maybe 5 wall loops. So we'd have a 2 millimeter thick wall or skin for the part, but we don't need it for this. So we'll again leave it at the default. Again, the speed we can leave in its standard configuration, but support we might want to add. Now, I'm not going to do the support first. So I've left support enabled, but let's do a preview. So what this will do is this will calculate the toolpath of the nozzle on the 3D printer for squirting out the plastic and making the part. And you can already see that the legs has floating regions. It doesn't like the fact that there's bits that would be in space, and so it's unlikely to print successfully. So if we go to support, and what we tend to do, go back to prepare, what we tend to do is use the tree, auto-generated tree supports. This tends to give us a support that's easier to break away and leaves behind a better finish. So let's see if you can spot the difference if we go back to the preview now. It should be quite obvious on the legs. There may be a little bit of support inside the head as well. This will take a little bit longer when it's printing, because it has to print the support as well as the actual parts, and it will use slightly more material because it's printing the supports. And there you can see in green it's added in some supports. These should just break away. And that's basically it. That's that file created. So to get this to print on one of our printers, you now export it to a memory card. For the purposes of sort of demonstration, I'll just show you on here. I'm going to go to File and Export, and I'm going to export a plate sliced file, and I'll just put that in Downloads for the moment and save it. And that file then can be transferred ready to go into the 3D printer. It gives you all the information here, what it's going to take. It's going to take a total of 5 hours and 35 minutes to print. It's going to use a total just under 165 grams of material. The reels that we get are a kilogram, so 1,000 grams. So you can see that some of it is for the model and some of it is support. And there's about 6 minutes preparation time. So by default, we get the machines to do a print test with the nozzle to make sure the filament's coming out, and also to do bed leveling, because it ensures more successes with prints. We get very few failures. But that's it. That's how to export the parts from Onshape and to import them into the Bambu Labs software ready for 3D printing. Thanks for watching.